Good morning, myself Gauri. Today I am going to present a topic on object relational databases. This presentation includes the contents as introduction, advantages of ORDBMS, creation of object types, security for object types, object weave, indexing methods, varying arrays, nested tables, and finally references. Starting with introduction to Object Relational Database Management System, that is in short ORDBMS. An Object Relational Database ORD is a database management system similar to relational database but with an object-oriented database model, that is objects, classes and inheritance are directly supported in database schemas and in query language. ORDBMS is a new technology in which relational and object-oriented concepts are combined. Since relational database is similar to mathematical relation, this similarity allows it to exploit many useful techniques and theorems from set theory. But these types of relational databases are not useful because of mismatch between application and DBMS and data complexity. Object-oriented database model allows containers like sets and lists and user-defined data types as well as nested objects. This brings commonality between application type system and database type system that removes issues of mismatch. And also, object relational databases are implemented as central server program rather than as a distributed data architectures. Causes for adapting to ORDBMS includes mainly abundance of information. Advances in the complexity of information causes drawback for databases. Relational databases are made for organizing data by common characteristics. Complex images, numbers, and multimedia products refuse such easy categorization. Second cause is isolated databases. Complex relational database systems lead to databases becoming islands of information where information cannot be shared easily from one large system to another. Next cause is structured limits. Some relational databases have limits on field lengths. When database is designed, the amount of data has to be specified to fit into a field. Some fields size is shorter than the actual data that leads to data loss. In order to overcome all these disadvantages, ORDBMS has evolved. Next concept is creating object types. Object types play an important role in ORDB. Main feature of ORDB is because of object types. Object types are created in order to group related attributes of a relation into one type. By grouping related attributes as one object type, that particular type possesses usual features of objects of object-orientedness such as polymorphism and abstraction. And command used for creating object type is create type command, and it should be used as shown in the example. In this example, the attributes such as item name, item number and item price, they all belong to the one object type that is called item details. Now, table uses object type for creating its attributes as shown in this example. Here, customer details attribute of relation customers is of object type item details. Hence, customer details has three attributes within. This illustrates reuse of code that has already written. As the object type item details is created explicitly, It can be concurrently used by many users and hence in many relations. This implements the features such as polymorphism and concurrent usage. In order to create relations which uses object types and insert values into it, syntax should be as shown in the example. In this example shown beside, two customers having IDs 1 and 2 have the same set of information. Use of object types reduces the overhead of adding those information repeatedly. This feature is of great advantages in case of large set of data. Next concept is about security of object types. Let us discuss about this with working in Oracle 10G. Address 3 is created by an user called as HR and person 2 object type is created by a user called system. But person 2 when using object type address 3, Oracle gives an error. This is because object types are restricted to intended users by which they are created. If any other users need object types, then owner has to grant privilege of accessing to them. System will not be able to create person 2 data type unless HR first grants them execute privilege on her type. In this example, HR is granting execute privilege on its type address 3 to system. Then system can create its type person 2 successfully. In this snapshot, values are inserted into a table which uses address 3 as object type. This should be used as hr.address3. This feature is purely from object-oriented concept. So object relational databases are secured because of object types. Hence, they can be used in user applications and many other applications where authentication is required. Hence, security feature makes it more advanced. Next concept is about object weaves. An object weave is a way to access relational data using object relational features. Object weaves provide the ability to offer specialized or restricted access to the data and objects in a database without altering actual database. There are two cases where object weaves can be created and used efficiently. One case involves a relational database created with object types, and if users want to insert data into these tables, they can do it with the weaves. This implementation is of not that efficient. Through this approach, a weave is created on existing object relation and then values will be inserted through the weave. This is similar to that used in relational databases, where select star command is used to weave the contents of a particular table. But there, only contents will be displayed unlike the weaves. They are not stored and hence could not be changed through the displayed things. If we want to alter the data, then we should use insert or alter command. But object relational database provides a feature in which displayed things will be stored into a virtual table called as weave, and through which existing table can be altered. Next case includes a table created with only built-in data types, not with object types. Such relational databases can be modified without rebuilding whole application. In this case, object types are created by observing carefully the existing relations, and using these object types, a view will be created. And through which an existing relation will be modified. So this includes a relational database need not be rebuilt with object types in order to be accessed with the help of view. That is, relational databases are operated with object relational features through virtual tables called as views. There are two main benefits of using object views. First, they allow creating object types that operate against tables that already exist. Second, the flexibility of data manipulation for object views, being able to treat the base table as either a relational table or an object table, is a significant benefit for application developers. Next concept is about indexing. A database indexing improves the speed of data retrieval operations on a database table. Indexes are used to quickly locate the data without having to search every row in a database table every time a database table is accessed. In this particular example, an index is created for a path customer details.address.city because customer is a object relational table. Customer ID attribute can be accessed without indexing because it is of built-in data type. But customer details is object type %ty and it contains attributes in turn as name, city and state. But these cannot be accessed directly. Hence, if they have to be accessed, then the column names of that particular attributes have to be specified. In this way, ICUS-city index is created. Methods. Methods are functions or procedures that can be declared in an object type definition to implement behavior that we want objects of that type to perform. Steps to implement methods for object types are: first, define methods that apply to object data types. Second, apply those data types to an existing tables. In this example, method age is declared in an object type as its member. Hence, keyword member has to be written. This function returns the age of animal. Writing age method body using the create type body command. In this example, a member function called age is defined within a type animal ty object type, and it is defined by using the keyword isBegin, and it should be ended with the keyword called as end. And this function returns the age of the animal in number of days. Here we should note that if more than one functions need to be defined, then they must be specified within the same create type body command after first end and before last end statement. This example shows creating object table called animal which uses animal as attribute whose type is animal ty, which is object type. This shows insertion of values into the animal table. In this, how the age method can be accessed is shown. First, an instance for table animal should be created, that is A. Age function is present within the animal ty data type, that is object type. Table has an attribute called animal whose type is animal ty. Hence, age method is accessed with that attribute name as a.animal.age. Here A refers to table animal first, and then a.animal refers to attribute of a table that contains an object type which includes age method. Hence, by moving into animal ty object type, age function is invoked. When age function is invoked, it computes the age of a particular animal and returns its age in number of days. Hence, age variable data need not be stored into the database. Instead, a static data such as birth date can be stored in database. Next concept is varying array. Varying array comes under the category called as collector. A varying array allows to store repeating attributes of a record in a single row. When we have to use the varying arrays, if there is a need to store only a fixed number of items or to loop through the elements in order, then we should use a varying array. To create varying array, we should use asVarray clause in the create type command. In this example, a varying array called tool VA of size 3 is created and the contents of tool VA are of type varchar. And in this snapshot, a table borrower is created that uses a varying array and values are inserted. And in first case, two values are inserted into varying array attribute which do not make any problem because varying array has size 3. In the next case, 4 values are inserted into an attribute of type varying array. Then Oracle gives an error. Exceeded maximum varray limit. Hence, varray type's size has to be changed and to do that, first table has to be dropped. It is because the table borrower uses the type tool VA. If we want to change that tool VA object type, again Oracle gives the error because it is being used in a particular table. So that particular table should be dropped first. Next, varying array has to be changed. Again, we should create table that uses tool VA as a type for its attribute. In this case, values are inserted without any errors. To access each elements from table borrower, first an instance of borrower table has to be created. Then, for table that exists within the borrower table, one more instance have to be created. For example, B is instance for table borrower and N is an instance for accessing an attribute named tools which is of type tool VA, which acts as a table rather than a single attribute. Hence, values in that attribute cannot be accessed directly by attribute name. Varying arrays support multi-valued attributes which are suitable for many of the applications. Next concept is about nested tables. This is second type of collectors. A nested table is, as its name implies, a table within a table. In this case, it is a table that is represented as a column within another table. Whereas varying arrays have a limited number of entries, nested table has no limit on the number of entries per row. We can have multiple rows in the nested table for each row in the main table. In this example, object type called as animal ty is created, and then a nested table named animal nt is created whose contents must be of the type animal ty, and it is called nested table because it is nested within another table. A table called breeder is created where animals is an attribute whose type is nested table. Hence, its contents have to be stored in a separate table called animals nt tab. And Oracle takes care of pointers to join main table and nested table. In the next example, values will be inserted. And in this, we can see how to access values from nested tables. In the first case, birth date from nested table animal CNT was accessed, but it cannot be accessed directly. In order to access that, we have to create instance for nested table which is pointed to or nested within main table. In this example, breeder name attribute is accessed directly and name birth rate attributes of type animals nt are accessed with an instance called n. In the next example, all the attributes of the nested table are accessed by specifying n dot star in the above command. And in the next example, a particular data is accessed by using where clause. That is, in this example, the name Julio is accessed. Advantages of object-relational database. First is reuse and sharing. Reuse comes from the ability to extend DBMS server to perform standard functionality centrally rather than having it coded in each application, and consequently this allows the functionality to be shared by all the applications. This is achieved through creating object types, varying arrays, indexes and tables which can be nested within any of the tables. Next advantage is increased productivity. User-defined abstract data types (ADTs) allow new data types whose structure is suitable for particular applications. Hence, this increases productivity for user as well as developer. By using this feature, many products can be developed. Next advantage is use of experience in developing RDBMS. Extended relational approach preserves significant body of knowledge and experience that are used in developing relational applications. User-defined routines UDRs provide the means for writing customized functions that have much of the power and functionality expressible in C. Improved concurrency. Users can safely query the same data concurrently because data objects will be created and stored separately which can be accessed by multiple users without disturbing relations. This feature is very much essential for advanced applications. Improved integrity. Ability to reject bad data before it is stored in an ORDB MS. In ORDB, only necessary and appropriate data are made as data objects, and object data will be reused while creating relations. Hence, unnecessary data such as attributes can be rejected from being added into relations. This is how integrity can be improved. References are Oracle 11G Complete Reference Book. This is all about small presentation on object relational database. Thank you.